Okay, we're going to review for our 5B test. The first part is going to be graphing complex numbers. So we want to identify the complex number represented by the star. So remember that our real axis will go first. So the number where this star falls on the real axis is a +2. And then using our imaginary axis, we can see that this is at -4. So we would put -4, and because it's on our imaginary axis, we will put 1. We would put I. So it is at 2 minus 4i. Now it's asking us to graph -4 minus I. So on our real axis, we're going to go to -4, which is here. And then on our imaginary axis, we're going to -1, which is right here. So this point here is at -4. This point here is at 2 minus 4i. Nope. So this point here is at -4 minus I. Okay, let's go on to the next one. We're going to be simplifying expressions. So for this first one, we're going to multiply. We're going to use distributive property. We're going to do 1 times 2, which is 2. And then 1 times 1i, which is 1i. Then we're going to do the same thing with the second term. We've got 3i times 2 gives us 6i. And remember, we want to place it under the other I. And then 3i times 1i gives us a +3i squared. Now remember, this I squared turns into a -1. So that changes this +3 to a real number. We're multiplying it times -1, so we get -3. So I'm going to put it under the other real number and cross it off on this side. So 2 minus 3 is -1, and then 1 plus 6i is 7i. Let's move on to the next one. Here we're going to subtract our complex numbers. So we're going to rewrite the first one, 1 minus 2i. And if you remember, this negative basically is going to get the opposite of the second complex number. So instead of +4, we get -4. Then +1i, we change it to -1i. And all we do is add 3 minus 4 is -1, and then -2i plus -1i is negative. On to the next one. The next one, we have 1 minus I squared. We've got 1 minus I times 1 minus I. And just like we did before, we're going to double distribute. 1 times 1 is 1. 1 times -I is -I. Do the same thing with the second term. -I times 1 is -1i. -I times -I is a +I squared. Remember, this I squared changes to a -1, which means we're going to change that +1 into a real number. -1 times +1 is -1. Cross it off, and now we're going to add. 1 minus 1 gives us 0. -1i plus -1i gives us a -2i. And then finally, we have adding complex numbers. We're going to rewrite the first complex number. Basically dropping the parentheses. We're going to write this one down right under it. And then we just combine. -4 plus 3 is -1. 5i minus 2i is a +3i. For the next part, we're going to be solving quadratics using the square root method. So the first thing we want to do is identify what is being squared, and then we want to isolate it. So in this case, we're going to subtract 4. We get 6x squared equal to -24. Still trying to isolate that x squared, so we want to divide by 6, and x squared is equal to -4. Then we do the square root. This cancels, and we get x is equal to plus or minus, and remember, we want to break up that -4 into a -1 times a +4. I'll move it up here. And we end up with plus or minus the square root of 4, which is 2. and then the square root of -1, which is I. So our answer for this one is plus or minus 2i. Let's move on to the next one. Identify what's being squared. In this case, we have this expression that's being squared. So because it's already isolated, we can start with getting the square root. So we have x minus 5 equals plus or minus the square root of 25. And the square root of 25 is plus or minus 5. So then we can move this plus 5 once, where we get x is equal to 5 plus or minus, and where x is equal to 5 minus 5. So we have two solutions where x is equal to 10 and where x is equal to 0. For the next section, we have a word problem. A man at the top of the building is 75 feet tall, drops a ball. The distance from the ball to the ground can be modeled by the equation 0 equals negative 3t squared plus 75, where t is the time in seconds. How long will it take for the ball to reach the ground? Round your answer to the nearest tenth of a second. Remember, time is only positive. So notice that over here we had two answers. On this one, we'll end up with two answers as well. But because we're talking about time, we would only want the positive one. So let's go ahead and solve. 3t squared plus 75. If the t bothers you, you can always change it to x. So instead of t squared, we have x squared. Let's subtract 75. And negative 75 is equal to negative 3x squared. Divide by negative 3. And x squared is equal to a positive 25. We do the square root. And we have plus or minus 5 is equal to x. Now remember, we're looking for the positive solution only because we're talking about seconds. So x is equal to positive 5. Okay, let's look at the next part. We're going to be looking at the quadratic formula. So for each problem, we first want to identify my discriminant to find the number of solutions, and then we're going to find the solutions. So we want to see if we can factor anything out. We can't. So let's start with labeling our A. Our B is negative 17. And our C is positive 12. So to find our discriminant, we go with b squared minus 4ac. And to eliminate any mistakes, let's put the parentheses first and then substitute. So my b is negative 17. Remembering your calculator, you want to put the negative 17 in parentheses and then the squared outside of the parentheses. Then we've got a, which is 6. And then we have c, which is 12. So if we do 17 squared, we get 289 minus 288, and that gives us 1. So because we get a 1, that means we have two real solutions. Remember, if it's positive, discriminant is 1, and we have two real solutions. If it's positive, we have two real. If it's negative, that means we have imaginary solutions. And if it's 0, that means we have one real solution. Okay, now let's apply the rest of the quadratic formula. So we have negative b plus or minus the square root of b squared minus 4ac, which is my discriminant, divided by 2 times a. So remember, 1 is going to take place of this whole thing. So we have negative b plus or minus the square root of 1 divided by 2 times your a. Your a is 6. And then the b is negative 17. Again, make sure that you put that negative 17 inside. So negative and a negative is a positive. We get 17 plus or minus square root of 1 is 1 divided by 12. So that's where we break it up into 2. 17 plus 1 divided by 12. And then 17 minus 1 divided by 12. Okay, 17 plus 1 is 18 divided by 12. We can simplify that by dividing both by 6. We get 3 over 2. And then over here we have 17 minus 1 is 16 divided by 12. And both of those we can divide by 4. And we get 4 over 3. So my two solutions are at 3/2 and 4/3. And again, it is the point where the graph touches the x-axis, what we're talking about. So my two solutions will be like this if you want to see it sketched. All right, and then for the next one, notice how they're all even numbers, so we can divide them all by 2. It is not necessary, but it will make your numbers smaller. So I'm going to factor out a 2 first, and we get 4x squared minus 2x minus 9 equals to 0. We can cancel out that 2. And now we have my a is 4, my b is negative 2, and my c is negative 9. So first we're going to find our discriminant, b squared minus 4ac. Set up my parentheses. Your a will go here. My b, careful with those negatives, will go here. And then the c will go here. We get positive 4. Negative 4 times negative 9 is a positive 144. That gives us 148. Because it's positive, that's my discriminant. And because it's positive, that means we have two real solutions. And now let's find the solutions. So we're going to apply the rest of the quadratic formula. And we have minus b plus or minus the square root of b squared minus 4ac, again, which is what we already got. Now it's 148, so that's going to take the place of this one, all divided by 2 times a. So we get negative b, set up your parentheses, square root of 148 divided by 2 times a. 2 times a. Your a is 4, and then your b will be negative 2. Again, inside the parentheses, exactly the way it is. Negative 2 is a positive 2 plus or minus the square root of 148 divided by 8. Now, I want to make sure that this 148 is simplified, so we're going to divide it by the perfect squares. And the largest perfect square that this one can go into is 4. Instead of writing the square root of 148, we're going to break it up to the square root of 4 times the square root of 37. Now remember, the square root of 4 is 2. And then we bring down the square root of 37. So we're going to write down 2 plus or minus 2 square root of 37 divided by 8. Now if you notice, all of these have a coefficient that is divisible by 2, so we can divide by 2 to each one. So 1 plus or minus the square root of 37 over 4. Solutions are 1 plus or minus the square root of 37 over